Hello, we will discuss feature subset selection today. As a recap, we have seen that feature selection is necessary most of the times. And why do we do it? To improve or maintain accuracy, to simplify classifier complexity, or in cases where the collection of data for each feature may be costly, and where overfitting may occur, and also to overcome the curse of dimensionality. For this video, I would be referring to this lecture notes by Andrew and also another paper. I will just tell about it. So this was the recap. Now feature subset selection. This portion I have taken from, referred from this paper. Of course there is a lot of material on the internet if we search for it, but this is a very initial paper. So feature subset selection is broadly categorized into wrapper methods, filter methods and embedded methods. So what is the wrapper method? Here we train using a selected subset and estimate the error. Okay, that means we use some algorithm and test the error on the validation subset. That is, we check the prediction accuracy. So they use the machine learning algorithms as a method or as a black box to score the subsets, that we are having different subsets and each is scored by some machine learning algorithm and we pick up the best one. So these are the wrapper methods. Okay, this is more kind of supervised method because we are validating the subset by its accuracy, which means we have the ground truth available with us. Next is the filter method. Here we are looking only at the input, so these are more sort of unsupervised methods. These select subsets as a pre-processing step independent of the predictor. See, in the previous case we had taken the predictor and used its scores to validate the subset. Here we are doing this subset selection as a pre-processing step independent of the predictor and we generate a score. Okay, that measures how informative each feature is about the class labels. So this is more unsupervised approach because we are looking only at the input and not at the target variable. Last is the embedded methods. These perform variable selection in the process of training and are usually in particular or specific to the given machine learning algorithms or learning machines. For example, in decision trees, we see that information gain is used as the variable selection, attribute selection measure, and then only the tree is developed. So this is part of the training method of the machine learning algorithm. So these are the embedded methods because they do the feature subset selection as part of the ML algorithm. Now, when we say we are evaluating subsets, feature subsets, then we must search for the subsets. So how do we do it? Like we have this big feature set which comprises of say F1 to say Fn, and we want to make choose a subset which will be say F1, F2, this is a subset 1 and then we have subset 2 which could be F1 with F3 and so on. See, we have already said that we do not want to enumerate all the 2 to the power n subsets. We do not want that. So we are taking a heuristic approach. So given a feature set F of n features, we are generating feature subsets of smaller size, usually smaller size. It may end up being the whole feature set. And what is the approach? The forward search approach. We start with the empty feature set. Okay, so we are starting with the empty feature set. So Fs is empty and then we add the remaining features. So at the first stage, Fs will be our Fs union the first feature. Okay, then we estimate the error because These subset search is required for the wrapper methods, where you are searching for the subset. The filter methods are evaluating the input on the basis of some score, on the basis of some like information gain or some measure. Okay, so they are evaluating this the feature set based on some measure and then creating the subsets with scores. But when you are searching for the feature subset, it is more applicable for wrapper methods. You can of course use this in combination for other methods also, the subsets which you are creating here. So what we just said, we start with empty feature set, add on features, estimate the error, then again we go on doing this iteratively. Stop when there is no significant change in the improvement of accuracy, or we could have other stopping criteria, that the number of features, we have decided on the number of features. So number of features achieved in this set, or no feature remaining. Okay, so this is the forward approach. This is a very simple approach, but moving in a more kind of adding on features, not for all these, blindly checking all the 2 to the power n. So this was forward search. So now the backward approach for feature subset selection. We start with the entire feature set and then we want to remove features, because we are actually planning to bring this fn features down to smaller subset. So we want to remove features. So which feature should you remove? Where the feature which is not reducing any error. Okay, so that feature is of no use. Okay, if the feature is not reducing error or increasing accuracy, that feature should not continue in our subset. Okay, so that is the approach to removing features. And then again stopping criteria, no significant change, or you have reached the desired number of features. So to summarize, we have seen that the wrapper feature selection algorithms take the approach of selecting subsets and then evaluating through some machine learning algorithm. But they can be computationally expensive because they have to call the learning algorithm for each feature subset. Okay, filter feature selection methods give us heuristic approach, but they are computationally cheaper in the ways they choose a feature subset. Finally, there is this point to keep in view, that having ranked the features as to which is the most valuable for the target and so on, how many features K to choose, this is a decision which the person has to make, the developer has to take. We could use the cross-validation set for this. So we stop here, and in the future videos we'll take some example of these different feature selection algorithms, and I hope you have got an overview of the feature selection and how the subsets are selected. Thank you. Thanks for watching.